Hello there, you're welcome to the channel. This is Henry's Class YouTube channel, and we welcome you all. If this is your first time of watching our video, consider liking, sharing, and subscribe. Thank you for your support and also for patronizing our services by watching our video. Now we are on vacations and students are in the house, so we've taken this opportunity to prepare some lessons that are very complex to students as far as their learning is concerned. And today we are going to look at mathematics, a topic in maths which is factorization. So if you are in Form 2 and Form 3, you are going to learn about factorization, which is a concept under algebraic expression. Today we are going to break it down. You understand it, we'll solve more examples on it so you can get better understanding of factorization. Alright, so factorization is a subset of algebraic expressions. And when we say algebraic expressions, what are they? So simply, algebraic expressions are mathematical statements that consist of numbers, variables, letters, and mathematical operations. And we all know the mathematical operation, the basic ones: the addition, the subtraction, multiplication, and the division. So basically, when we talk about an algebraic expression, we are talking about a mathematical statement. The mathematical statement here simply means that you have some terms, you have some variables, some numbers, okay, and in these terms or variables or numbers, you are only finding operations. You are finding variables like letter x and y and so on and so forth. We use them to represent our real life situation mathematically, and they are also used for factorizations and equations. That is algebraic expression. Let's look at a real life example. The number of students in basic 5 is 10, more than the number of students in basic 6. Write the number of students in basic 6 mathematically and hence find the answer. So when you happen to meet a question like this, you shouldn't find it very challenging. This is very simple to do. So they are saying that in a class called basic 5, the student there is 10, more than the number of students in basic 6. So what it means is that, so let's do a little correction here. Let's make it basic 5, sorry. So in basic 5, the student there is 10 more than those in basic 6. What this simply means is that if you take students in basic 5, if you want to get the number of students in basic 5, you would have to add 10 to the number of students in basic 5. In basic 6, you would have to add 10 to the number of students in basic 6 to get the number of students in basic 5. So let's assume we don't know the number of students in basic 5. Let's represent it as b. So this is why we'll say b is equal to x. So anytime you see statements like this, we are doing algebraic expression. Okay, that's b5. Okay, b5. Then b6, which is basic 6. Alright, so let's read the statement again. It says that the number of students in basic 5 is 10, more than the number of students in basic 6. So if in basic 6 we have only x students, let's say we don't know, so x students, to find basic 5 we would have to add 10 to those in basic 6, so x plus 10, in order to get the student in basic 5. That is what this statement means. So algebraic expressions are used to represent our real life situations, problems we meet all the time. We use algebraic expression to represent it. Always my students would ask me, say, you always say we should find x, and when are we going to find this x? The x that we always ask you to find is a variable that is representing something called an unknown. So in math we have what you call unknown. So something that will be expressed abstractly, to be expressed without you not seeing it, without you not having a feel of it. But we use something to represent that unknown, which is called a variable. It could be variable x, y, a, b, c. So when I ask you to find x, that x is not a human being, but that x is representing something you do not know. that is where we use these variables called x and y. I believe I've explained a bit for you to understand. Now let's take note of the following. I'll be mentioning some of these things. We have what we call terms. So when you say terms, they are parts separated by addition or subtraction. So if you see 5x standing alone, it is a term. We call it term 1. If you see 3y standing alone, we'll call it a term 2. So in this case, how many terms do we have? Just 2. Okay, so anytime you have 2, 3, 4 expressions separated by addition, then we have a term. We have what you call like term. For me, I locally call it lookalikes for my students to understand. So these are terms with the same variables and powers. When we say powers, all these letters you see, this x has a number on top here which you call power. So this one has a power of 1. This one also has a power of 1. When you look at this x, there's a 2 on top. So here the power is what? 2. So anytime the variable has the same power, then we are looking at what? Lookalikes or like term. Unlike term, terms with different variables or powers. So if we have a term with different variable, different powers, we don't call it like term, but unlike terms. All right. Okay, let's dive much deeper. So we have factorization. When we say factorization, it's the process of breaking an expression or number into simpler factors. That's the meaning of to factorize something. You break a larger expression into a bit or a smaller expression, simply into what? Simple factors. So we have what you call simple factors or common factors, and we'll look at what they are. That multiply to give the original expression. A clear example is here. Now we have 12. 12 can be calculated using 2 times 2 times 3. I believe you recall your idea in prime factorization, or what you call factor tree. Okay, so in that concept, we would explain to you that we can use prime numbers to represent a number by writing those prime numbers as a product of themselves or of other numbers. We also have 8 plus 4b. 8 can be represented as 4 times 2. Alright, 4b can be represented as 4 times b. In this case, we call something a common factor. When you check this first bracket, 4 times 2, there's a number that is also appearing in the second bracket, which is 4 times b, and that number is 4. So we'll say we have factorized 4 out. So 4 will be written outside here, where a bracket will be introduced to write the remaining terms. So here we have 2 left here, so 2 plus we have b, so 2 plus b. This is it. We can simplify this back to this. How do we do that? We just multiply this 4 by 2, and that'll give us 8. We multiply this 4 by b, and that'll give us 4b. So if you recall, in the third or the fourth slide of this presentation, it was said that mostly they multiply to give what? The original expression is even here. That multiply to give the original expression. That is factorization. Alright. A real life situation here. A teacher has 36 pens and wants to pack them equally into boxes. If each box must have 4 pens, how many boxes will be filled? So a teacher is having 36 pens. 36 pens. And out of this 36 pens, he wants to pack them into 4 boxes. Into boxes where each box will have 4. So this clearly means 4 in each box times a certain number of boxes is going to give us all the 36, and clearly it is what? 9. So 36 can be represented as 4 times 9. 4 times 9. That is the idea. What it means is that each box 4, the total number of boxes will be what? 9. Now we have 4 types of the factorization. We'll take them one after the other. Let's look at the first one called the type 1, common factors. In type 1 common factors, we make good use of what we call the common factor. The common factor is any number that can divide the terms or the numbers in the terms exactly without any remainder. So how do we do type 1 factorization? First, you identify all the terms and then you place them in brackets. Step 2, you find the highest common factor of the coefficient. What is coefficient? Coefficient is the term or the number that comes before a variable. Okay, so if I have 2a, now ask you the coefficient of a. The coefficient of a is what? 2. If I have, let's say, y, the coefficient of y is 1. If you recall, you'll be seeing 1y, 2y, 3y. Those numbers you see in front of the variables, we call them coefficients. Then divide each term by the highest common factor. Write the expression as the product of the highest common factor and the simplified expression. In simple terms, you can always factorize using type 1 by having the greatest common factor, which is also the highest common factor, out, multiplying the remaining terms. A short example here, 12 plus 8. When we look at 12 plus 8, this 12 can be represented as 4 times 3. This 8 can be represented as 4 times 2. When we check these two, there's a common number that is appearing in both. That's 4 and 4. So we say factorize 4 out, and 4 is out. What is left here is 3 plus what is left here is 2. When you simplify this, you get back to this. 4 times 3 is 12, 4 times 2 is 8. In the second one, we have x power 2 plus x. So here the power of x is 2 and the power of x is 1. This x squared can be represented as x times x, meaning the x's are 2. Whilst there's just one x. This x here means x times 1, because x times 1 will give you x. X times x will give you x squared. The common term here is x and x. So we factorize that x out. Still there's one more x left plus our 1. When you simplify this, you'll get back to this. That is factorization. Let's look at a critical example. Factorize the expressions 8a plus 12ab. So first then, what is the highest common factor of 8 and 12? The highest common factor of 8 and 12 is 4. So please, if you have a challenge with the highest common factor, please kindly revise your notes on that. But we'll also do a lesson as to how we can find the highest common factor. We'll guide you on that. So the highest common factor is any number that can divide 8 and 12 equally without a remainder. When you look at 4, 4 times 2 will give you 8. 4 times 3 will give you 12. So 4 is the highest common factor of 8 and 12. Aside that, there is a and another a. We'll say the a is the common factor. So we factorize both the 8 and the a out. Sorry, the 4 and the a out. So we have 4a outside the bracket. Now, what is 8 divided by 4? 2. Okay, plus 12ab. Here, what is 12 divided by 4? The answer is what? 3. And here we factorize a out. So what is left? B. Very simple to do. Let us go through the explanation again. Here, the highest common factor of 8 and 12 is 4. So your 4 is here. The common factor of these two terms is a. So a is out. Then you ask 8 divided by 4 will give you 2. In other words, 4 times what will give you back the 8? That is 2. Plus. Then 12 divided by 4. That is 3. You've already taken a out. So what is left? B. You can write this in a different way, as the 8a can be represented as 4a times 2. Okay. Then the 12ab can also be represented as 4a times 3b. times 3b. Alright, when we look at these two, the common factors are 4a and 4a. So we factorize 4a out. What is left here? 2 plus what is left here? 3b. And that is what we have here. 4a brackets 2a plus 3b. The second one, we have 4b plus 10. So the highest common factor of 4 and 10 is 2. Here there is no common factor. So what is 4 divided by 2? 2b. So 2 has been factorized. 2b out. 2 into 10, how many times? 5. So 2 times 2b will give you 4b. 2 times 5 will give you 10. And this will be your final answer. You can do this in a different way as 2b times 2, okay, plus 2 times 5. The common factor is 2 and 2, so we have 2b plus 5, and that is all. The second example, we have factorize ab minus b squared. 7a squared b plus 21a squared b. So ab minus b squared, you place it in bracket. What's the common factor? Here when you check critically, b can be found here, b can be found here. But the difference is that here the b is 1. Here the b's are 2. So what do? You pick just one. This how it goes. So let me expand it. It becomes ab minus b squared simply means b times b. That's the meaning of b squared. So what's the common factor? There is one of the b here, there is another one of the b here. So b will be factorized out, b will be taken out. Then what is, if b is taken out from here, a is left. If here the b's are 2 and 1 has been taken, meaning how many b's left? 1. So you have a minus b, a minus b. B times a is ab. B times negative b is negative b squared. Always when you multiply, you would get back the original expression. If not, then your solution is wrong. 7a squared b plus 21a squared b squared. The highest common factor of 7 and 21 is 3. Now, aside that, a squared is here and another a squared can be found here. They are common factors, so we factorize them out. The case of b has happened here again. 1b here but 2b here. So what do you think? We factorize just one of it. Since here there are 2, b times b, b times b. One of the b will cancel out the other one. So b are cancelled, the other b. So 1b left. Now we factorize 7 out. Okay. So what is left here? We also factorize b out. We factorize a squared out. It means what is left there is not 0, but rather 1. Anytime you factorize and there is nothing there, replace it by 1. So when you multiply 7a squared b times 1, you still get back your 7a squared b. 21 divided by 7 will give you 3. Here we factorize a square out. We factor one of the b out. So what is left? Just b. Then the final question, we have 4 times 3.55 plus 4 times 6.45. We have to evaluate this. The common factor here is 4. So we factorize 4 out. And that is what you are seeing here. We are left with 3.55 plus 6.45. That is what we have here. When we sum it up, we have 10.0. 4 times 10 will give us 40. 40. Alright, so this is type 1 factorization questions. Okay, so now I want you to try your hands on these questions as homework. 3a plus 6, 10ab minus 15ab squared, and 15 times 1.33 plus 15 times 1.67. You can send your assignment to 0599 123 or you can email me, that is henryobison6060 at gmail.com. I would mark and then give you your score. If there's any correction too, I would assist you over there.